Hello, this is Darren Pulsifer, and welcome to Embracing Digital Transformation, where we investigate effective digital transformation using people, process, and technology. On today's episode, we're going to talk with Greg Clifton from Intel Corporation about Follow the Bit. This is Darren.
This is Greg.
And today we're going to talk about Follow the Bit. Greg is our director in DoD and
intelligence.
Thank you. I can't remember the word intelligence this morning. And today we're going to talk about Follow the Bit.
That's right. Yeah, we've as we talk to our customers in this space and you look at what they're trying to do with their complex mission environment, try to break it down and make it simple. And as I was thinking one day, it's all really just ones and zeros, right? And what they're doing is just bits of data. They're either collecting it, creating it, and then they've got to process it, move it, analyze it, do something with it for mission effectiveness so commanders or analysts or others can make decisions on it. And so that's where we came up with this follow the bit, right? It's just bits of data moving from the edge to the core to the cloud in this big circular environment. So we're trying to provide information and data to those that need it in a timely manner.
So it's interesting because when you and I first started talking about this concept of follow the bit, it doesn't just apply to DoD and intelligence. We're seeing it across all government agencies.
That's right. That's right. Any mission environment, any business environment, it's all data, right? And everybody's talked about the importance of data. Well, what are you going to do with it? And that's where Intel comes in, right? Where we try to help these folks at the underlying level process the data, move the data, store the data, so you can do what you need to do with it, either now or in the future.
Now, what's really interesting about the Department of Defense and Intelligence is just the vast amount of data and also all of the different types of devices that are collecting data.
Right.
That's very unique from other businesses or other industries, period.
It is. I think to some degree it's similar in a lot of ways as well. And I look at it traditionally, we've worked in the information technology space, but more and more it's that operational technology space. And again, the reason sort of thought about that follow the bit is it doesn't really matter what the data is, because it's all about, well, how do I process it? How do I break down bottlenecks, right? If I'm having a problem getting data from point A to point B, what is it that I need to do to speed that up? Or if I need to send data out to disparate places, what's the right data architecture to make that happen? How do I secure it? How do I do all those things? So whether it's radar data or it's, processing grocery information, it doesn't really matter, because it's just data, just zeros and ones.
The unique thing that we see in Department of Defense, though, is that it's very complex because of the number of different types of devices involved and the different. You said that it's just data, but the data comes in different classifications.
Yeah, the different domains that you got across and the security boundaries, the governance, all those kind of things are absolutely complex, right? So that's what makes it difficult, and just the natural stovepipe nature, right, of different missions and different agencies and what they're trying to do. They do their best to share data, but that's just not the reality of the way it works. So that's why it's so important, right, to come up with a common data architecture and a common operating environment.
All right, let's talk a little bit about Department of Defense and what we see out there that makes it so unique. So you talked a little bit about, radar and things. So what sorts of things do you see out there on the edge that would be unique to DoD and intelligence?
One of the unique things I think is just the speed, right? So whether, again, it's something on shipboard or on a vehicle or airborne, it's the speed with which they need to move the data, share the data, but it's also that disconnected quality as well, where you're out at the edge. Is that where your systems are that actually are helping you get those answers? And that's sort of what's changing, is the need to really get all of that processing and analysis out at the edge where the data is.
All right, let's talk about
to increase that speed.
Yeah, let's talk about that a little bit more. Give me an example of maybe something on the edge. You said disconnected. Why would you ever have an edge disconnected? I don't understand.
Well, so soldiers, as an example, you're out in your battalion, you're in theater, and you're driving around the street of a city or environment. You may have SATCOM, satellite communications, and you may have intermittent bandwidth, but to some degree, you're disconnected. But you still need the situation awareness. You're collecting data. You've got intelligence folks that need to send you information. If you're going into this village or that town, you want to know what you're going into. So it's the ability to do something with the data that you're actually collecting. Or say you send out an autonomous vehicle to go see what's around the next corner, feed that back into your environment, into your system. So I really understand what my people are getting into versus having to collect that data, send it off via a low connection SATCOM link to
And
some
wait for the
analyst at the
result.
Pentagon, right? That's not the speed of mission that they need. So,
All right, so it's interesting what you said because there's a couple interesting concepts. One is being disconnected and then partially connected. Because you mentioned, hey, I am gathering data, I'm sending it up when I have connectivity, maybe getting additional information. So you need to be able to work in both those types of modes.
that's right. And obviously they want to be as connected as they can all the time, and they're working to enhance that and make sure that they've got the connectivity, the bandwidth that's needed. But yeah, that's the environment. Sometimes you will be, sometimes you won't. It's just like a car, right? And as we look at autonomous vehicles, you go through a tunnel. Are you connected or aren't you? It's the same kind of environment out at the edge in the field from a
Well,
DoD
that's why an
perspective.
autonomous vehicle has to run disconnected, right?
That's right.
Otherwise, it crashes.
That's
into
right. And that's
things,
the
right?
same thing for our Department of Defense, our warfighters at the edge. They've got to run in all those environments.
Okay, so what's unique? Another thing that I thought was fascinating is some of these edge devices are data centers themselves, like consider a ship or an aircraft,
That's right.
right? They've got 50 processors in there. I mean, it's a
Oh
big
yeah.
deal.
Well, you figure what you need to crunch those bits of data. It's very workload and mission dependent. Yeah, you take ships as an example. I mean, those things have full data centers on them. Now they're modified based on the size, weight, power constraints. Or you look at some of these aircraft. These surveillance crafts or intelligence crafts. I mean, they truly have not even small, good sized data centers flying around. Uh,
Okay, so now let's talk about some of these edge devices that do need to communicate. They do need to share information where it gets all the way back to the analyst that may be sitting somewhere because I've got all these drones, people, boots on the ground type of thing.
yeah.
They're all collecting data that needs to be correlated somehow or can be to give even better mission awareness. So, how do we go about handling that? That seems like a nightmare.
It it is a nightmare. It's one of the problems, and I think you and I have talked about it before. That's where some of the data architecture strategy comes in, and instead of trying to recreate the wheel for every mission to create a new data environment and send it out, we need to help find ways to make it portable, make it reusable, and again, make sure that the data is in the hands of the folks that are making decisions quickly. Right now, we have tons of data. Collecting data isn't the problem,
It's
but
managing it.
it's parsing through it, it's managing it, it's knowing. Well, I just collected this information, or even look at a Homeland Security type application. Well, I've got videos of all kinds of license plates and those kind of things, but do I know that that license plate is the one that I should have watched or should have known about? Again, it goes back to the speed. You've got the data. Now I've got to process the data, and I've got to have the algorithms to give me answers. And a lot of times, even the answers I don't know that I should be asking the question to. Right?
So you mentioned every time I deploy a new application, I have to manage the data myself in that application. So we're working to come up with a common data architecture that I can drop several applications on.
Yeah, that's right. Whether it's a virtualized environment or a containerized environment, I think, use containers in a broad sense, but I think a lot of our customers would love that ability to just containerize a service and push it out to those that need it. And it's there and they run it and it's just like an app. And then when I'm done with it, it's gone, but it can be reused next time I need it.
All right, that's really interesting because there's several aspects that we have to come up with when it comes to this common architecture to help us build applications that span this vast ecosystem of devices, ground stations, tactical edge devices, data centers, clouds, all these
Right.
things that are all combined together. So we talked already about a common um, data architecture. What other things fit into that same thing?
Well, one of the things we're working on, as you know, is trying to have a common underlying uh, development platform. So things like Intel's One API is an example of trying to create more of a heterogeneous compute model so that you don't have to optimize for every specific compute element or every widget that's out there, but I've got the ability to write my applications once and then optimize them and deploy across any type environment, whether that be a large server with a Xeon inside of it or a small little embedded device with an Atom or a Core i5 on it, right? As a developer, you just want to be able to do that once, write your application,
and then run anywhere.
yeah, make sure the infrastructure just works.
Well, and then even taking advantage of even accelerators, you like an FPGA
Right.
or neuromorphic chip or even a GPU.
Well, yeah, because as I say that, right, that you want a common development environment, the reality is the world is going to application-specific type processing and workloads because it is getting complex. You don't just have a one-size-fits-all. And that's the beauty of what we're trying to do at Intel is we are bringing forth a portfolio where you've got different ways to process workloads, whether it be your typical CPU, but GPU, FPGA, accelerator, video processing units. It's all needed based on, as you said, you look out there at the edge, there's all kinds of environments and all kinds of data that you have to process, and you need the right engine to do so.
Sounds great. Now, another key foundational thing, I now have data all over the place. They're in devices that are out in the open.
Right.
So another key aspect that we're hearing a lot is security.
Well, yeah, of course, right. That's the tricky part is how do you secure all that data in flight, at rest, in processing, but not put so much around it that you can't share, right? We talked about being able to share the data, move the data, get answers to the right people. Certainly building hardware level security hooks and then software level security hooks. I think that we're making a lot of progress as a ecosystem and as an industry, but more work to be done there. And certainly, one of the easy things to do is just encrypt data, right? Encrypt it round trip, and that would be an easy fix. It's kind of like in the security world, just do patches, and you'd be significantly more secure, right, than you are today. So it's some of those things I think it's not simple, but it's things that we should just be doing.
But it should be foundational, right?
Foundational, right, exactly. And that's part of where you do need the right amount of processing capability and storage capability to do that, right? That's why it is so important to pick the right engine underneath these workloads so that you can do things like encryption, but also be super fast and have the speed you need to process the mission.
So we talked about data security a little bit. There's another aspect of security which is kind of hidden. As soon as I go into the IoT space, now I'm willing to accept data from lots of different sources. So
Right.
what's going to prevent someone from injecting a new device into my ecosystem and kind of spoofing me, right? And now I'm getting data, erroneous data from someone, a nefarious, enemy or whatever it is. I mean, how do I prevent that from happening? 'Cause
You tell me, Darren. That's a good question.
Yeah.
It is. It's a tough one, right?
I think this goes into establishing a root of trust.
Yeah.
So when someone talks to me, they're handing me a key that only they and I have,
That's right.
right? But this is a huge problem that you have to address. If not, you can encrypt all the data you want. Doesn't
That's right.
really matter. Someone's going to feed you a bunch of garbage data, and it's going to make a mess of your
Yeah,
system.
and that's one of those things you see some of the pictures we drew that edge to core to cloud, but there is a whole large key exchange infrastructure and the whole root of trust. You're right, that's important. It's something we've been talking to our government customers and partners for a number of years is establish that hardware-based root of trust. So you at the lowest level, even below the operating system, right? You got to have that low level, make sure that this is the information, the data that should be there, and that it's got the right permissions and the right handoffs to make that happen.
Great. All right, now let's take a look at kind of why is Intel talking about this? Why? I mean, come on, we don't do big system data things, do we, or do we not?
Yeah, so Intel has always historically been you can equate it to building a house, right? Where the plumbing and the electric and all the things that make the house actually work and operate and run. And that's what we do to provide capabilities to process that data, to move the data via the network processors, and helping to do speed up network transmission, and then store the data on SSDs or in memory on the system. So it certainly is important, just like you would look at the operating systems and the application layer as being foundational. Well, they don't run unless you have hardware underneath. And so, as I mentioned a little bit earlier, we've been trying to focus on making sure that we've got a broad, well-rounded portfolio, all based on very similar instruction set architecture. So you can write applications once and deploy many places, but you've got the right tool at the right either performance envelope or the right power envelope. So you've got to have that mix and match of performance and power. So size, weight, power absolutely matters, particularly when you're looking at edge applications and you only have so much power on a vehicle or a ship or a plane. But even in a data center, right, you've got to have that right mix. You don't have unlimited power, unlimited cooling. Some of our customers, they talk, you've really got to have the maximize sort of that operations per joule, right? It's that trade-off of how much can I process for how much heat, right, do I produce, and how much can I cool? So we've got all the way from 1 watt or less type processing, all the way up to hundreds of watts of power produced on that processing. And you've got different capabilities everywhere in between.
So not only generalized processors, but also accelerators, and then even custom ASICs is something that Intel is involved in as well, right?
Right. And I think that's really pretty exciting when you look at where's the future of computing going. We went from a lot of customized environments to everything off the shelf, but when you're looking at competing against your competitors, whether that be in business or nation states, you have to figure out a way, how do I take something, and even if we have a term differentiated cost, and I take something that's commercial off the shelf, but maybe I tweak it a little bit that gives me a very unique capability and a differentiation over others. And that's where some of these accelerators, FPGAs and eASIC, which is really just taking an FPGA and creating an application specific integrated circuit, which is less costly and less power, to some of the other things that I mentioned, like the video processing unit. So it's been a pretty exciting time when you have all these capabilities in your portfolio, and you can really talk that full data life cycle that we can help you process and move and store it.
Well, hey, Greg Clifton, this has been great, Greg, to hear all the different things that Department of Defense and Intelligence is facing. Complex problem, a problem that we're trying to solve with the ecosystem and also with our silicon. So thanks.
Yeah, I appreciate it, Darren. It's a conversation just like we're having with our customers. It's not a silver bullet, one thing fix all. It's multiple conversations and discussions to get to that right solution. So thank you.
Thanks for listening to Embracing Digital Transformation today. If you liked our episode, go ahead and give us 5 stars on your favorite podcast or video streaming site. You can also find out more on embracingdigital.com. Until next time, keep moving forward and embrace the digital revolution.